Okay. Consider the data set. So they give me a bunch of numbers. Find the average, find the median, and do all that kind of stuff. All right. So, yeah. So let's see. How do you find the average of a bunch of numbers? How do you do that? Let's start with part A. So average. Let me give a good example. Let's go to this page. Let's find the average salary of Naval Academy grads. Whoops. Grads in math. So here it is. 45,000, 47,000, 48,000, 49,000, 51,000, 51,000, 54,000, 55,000, and 230,000. So these are students that graduated from the Naval Academy in Annapolis. You know, the Naval Academy, United States Naval Academy in Annapolis, Maryland, I think. Where it is, Maryland? Anyway, the Naval Academy. So there's their first year's salary. They graduated in math. This is math up there. I kind of scribbled it. So these are people that graduated with a math degree from the Naval Academy and the first year salary. So what's the average? So like if you were thinking about majoring in math, you got into the Naval Academy, and you were thinking about majoring in math, you thought, what will I make? What will be my income? You know, and you looked up some information on the average income of people that graduated with a math degree from the Naval Academy. How could we figure out the average? What would we do? How do we calculate an average? One at a time. I'm just kidding. What do we do? Add them all up and divide, right? So it's a little tedious. So 45 and 47 and 48 and all divided by how many other? 1, 2, 4, 9? I think 9 of them, right? So you add them all up and divide by 9. If you do that, did I do that? No, 70. Comes out 70,000, I think. 70,000. So there's the average. You guys know about average. That's not anything new. Oh, it's called mean, by the way. The official name is it's called the mean. There's technically 3 kinds of average. Mean, median, and mode. We'll be talking about those. But, typically when people say average, that's the one they mean, right? But technically, average can mean 3 different things. So that's the mean average. You add them up and divide. So now, is that a good average? Is that doing a good job of being an average? Like if you were thinking about, you're at the Naval Academy, you're starting in the fall in Annapolis, and you had to pick your major, and you're thinking, should I major in math or maybe English, or what am I going to major in? And you say, well, I'll check out the salaries. See what people make that graduate with a math degree or an English degree or whatever. And you looked up math, and it said average salary, first year out of college, for people that majored in math out of the Naval Academy last year was 70,000. You're thinking, wow, that's pretty good. First year, math major. I think I'm going to major in math, right? I'll make 70,000 my first year out. That's the average. So that's not good, huh? Because you're probably not going to get $70,000. Because of what? What's causing the problem with that average?
The one person making a lot more than everyone else.
Yeah. It's $230,000 salary, first year salary out of the Naval Academy. It's throwing the average way off, right? I mean, reality, you should expect to make somewhere around $50,000, right? That's what the typical person with a math degree, which is what average is supposed to do. You agree with me? It's supposed to give you a feel of the middle, of the typical. And in this case, it's not doing a very good job, is it? What's with that 230? This is actual, those numbers aren't exactly right, but they're close to right. I don't know if you know that this was back maybe 20 years ago. There was somebody that graduated with a math degree from the Naval Academy and started at a salary something like this, might have been even more. Really good at math. No. Really, really good at shooting the basketball. Mr. David Robinson from Spurs, now is he Hall of Famer yet? Sure he will be soon. Anyway, David Robinson graduated with a math degree from the Naval. I don't know if you remember back 20 years ago. Some of you guys weren't even hardly alive 20 years ago. But it was big news that David Robinson was like, no, I'm going to wait. They wanted to draft him. And he's like, I'm going to finish up at the Naval Academy. And the Spurs were like, be careful with our David Robinson Navy. Don't be shipping him out here and there. He's big bucks to us. So anyway, right, first year out, and then he finished up and he joined the Spurs, and the rest is basketball history. He made, so not because of the math degree, but he's throwing the average way off, right? He's killing the average. So because of that problem and problems like that, real life, we have another kind of average. You guys heard of median before? Median is another kind of average. Now, what's median? Anybody know, like, median's another average. That's what it is. But how do you do it? How do you figure out this? We need it because this one's not doing a very good job. It does in some data sets. Basically, if you have super big numbers, the add 'em up thing doesn't do a good job of giving you the middle. That's what average is supposed to do, right? Give you the middle. So if you have really high numbers, you don't want that. You want median. Now, what's median? Does anybody know? Nobody knows? Basically, in median, you order them lowest to highest. So you put them in order from the lowest to the highest. They already are in this case, right? 45 is the lowest and 230 is the highest. And you take the middle number. That's it. You don't add anything. You just put them in order and you grab the one in the middle. Now, which one's in the middle? Which number is right smack dab in the middle of the data set?
51,000.
Which one? Yeah, you're right. It's this one. Because there's 4 numbers after it and 4 numbers before it, huh? It's the smack dab middle. It's the middle number. So that's it. Done. So the median salary would be 51,000. That's much more what the average is, huh? That's what the person should expect to get who graduates with a math degree from the Naval Academy, right? 51,000. So you see how median does a better job? Now, not always, but for data sets that have big numbers in them, median is the kind of average. If you and where does that happen? Real life? You watch the news or read things on the internet. If it does house prices or salaries, they'll always say the median house price in Fresno, the median income in Fresno, the median income in California, the median house price in California. They'll always do median, they won't just say, they might say average, but they mean median. Usually they actually say the word median. Most things I read, they literally say the word median. And why are they doing median? For exactly this problem. Because there's some houses that are worth millions and millions and millions, and some salaries that people are making, the professional athletes and other people that are making lots and lots and lots, which would throw the average way off if you added them up, right? So they do median, which just means put them in order and grab the middle one. That does a better job in those kind of data sets of giving you a feel of the middle. So that's another kind of average. So we have 2 kinds. Mean is the add 'em up. That's the official name for the add 'em up, divide by how many. Median, there's actually a third kind. Does anybody know the third kind of average? Now, range is just high minus low. We'll get to that. It's, that's right, I said it a minute ago, huh? The third kind is mode. That's the third kind of average, is mode. Mean, median, and mode. Those are all averages. Mode is the number that occurs. It's the number that occurs most often. That's it. You don't add them up and divide. You don't put them in order. You don't do anything. You just say, hey, what number occurs the most often? That's the average. Now that seems kind of weird, doesn't it? I mean, what if the top number occurs the most often? Is that the average? Well, yeah, see, all these things depend on the data set. Depend on like, what if I asked you guys, hey guys, what's the average number of children per household in America now? It's going down a little bit, I think, over the last 20 years. What's the average number of kids? I'm helping out. I'm contributing 5. What's the average number of kids per household in America?
2.
Probably 2. Now, we don't say, well, they kind of do jokingly say it's 1.7 whatever. And the joke is the point, actually, huh? You can't have 0.7 of a kid, right? So no, the whole joke is, yeah, we added them up and divided. Well, that's the wrong kind of average. We all sense it, right? So the right kind of average for number of kids is mode. Just like what do most people have? They have 2 kids, 1 kid, 3 kids. What do most people have? That's what we mean. We mean what's the most frequently occurring number, huh? Same thing with shoe size, for example. Somebody said, what's the average women's shoe size? They don't mean add them all up and divide, do they? 8.21374. If I went into a shoe salesman, went into some shoe store, and I said, hey, what's the average women's shoe size? They wouldn't say, well, it's 8.314 according to this chart. They wouldn't say that. They would say it's 7.5, or it's 8.5, or 10.5, I don't know. They would say the one that occurs the most, wouldn't they? That's what they would say. That's the other kind of average, mode. So it depends on the data set. Some data sets, the average is best described by the one that occurs the most. Sometimes it's best to just grab the one in the middle after you put them in order. That's median. And sometimes it's best to just add them up and divide. They're all forms of the middle, but they all do better and worse jobs of really giving you a feel of the middle, depending on the data set. Okay, so with all that information, let's go answer the questions. So here's our question. Question number 1 in 14.2. Consider the data set. Find the average. And when they say average, they mean the add 'em up thing. So average means add up. Add up and divide. So basically I've got to take these numbers, 6.9, all these numbers here, negative 0.6, negative 3.2. You don't need to go plus and negative, it's just minus, whatever. Minus 0.6, minus 3.2, minus 1.7, minus 1.7, minus 0.1, minus 3.2, minus 11.4. Divide by, how many is that? 1, 2, 3, 4, 5, 6, 7, 8. Divided by 8? Yeah. So I guess if you have a calculator, it'll come out to be that. Minus 1.8750. They want 4 places, so I guess I got to throw that 0 on the back. Is that good for starters? Part A just says find the average, which just means use your calculator, add and subtract them all together. It comes out negative. That's kind of weird. I don't know what maybe it's average temperatures or something or whatever. So add them up, divide by 8. That's just average. Now part B is a little more tricky. Find the median. So find the median. So we just talked about it. How do we find the median? So what should I do first to find the median? Got to do what? Put them in order. Yeah, we got to order them, huh? Remember, yeah, good. I'm glad you remembered. That's real important because I always had some people on the test that they just try to grab the middle one right away without ordering them. So good. I'm glad that you're remembering that. So let me write that again. So I'm on part B now. I'm on the median. First order low to high. So put them in order from low to high. What's the lowest number up there? And those 8 numbers. Can you do that on your own papers? Can you go ahead and just order those? Start with the lowest number, comma, the next one, comma, the next one, comma, the next one. Just order them from lowest to highest. Where do we start? What's the lowest one? You tracking with me that it's the negative 11.4, because that's the most negative. So that one would be first. Keep going. Then it would be the negative 3.2, so they're both the same. Negative 3.2, negative 3.2. Keep going from the most negative on up to the most positive. Just think about money. That's like $11.40 loss, $3.20 loss. You know, it's getting better and better. Less and less loss until it's actually gain. So negative 1.7, negative 1.7. Then negative 60 cents and negative 10 cents, huh? And there's only one positive? I guess so. You know, on a test, it'd be good just to count them, make sure you didn't lose any, you know? There's supposed to be 1, 2, 3, 4, 5, 6. Wait, how many? So what am I? Oh, I skipped the first one. Man, oh man. 1, 2, 3, 4, 5, 6, 7, 8 of them. 1, 2, 3, 4, 5, 6, 7. Yeah, 8 of them. So it's looking pretty good. I probably have them all. Okay, so grab the one in the middle. Let you do that. So now that you have them in order, grab the one that's in the middle. Which one's in the middle? There's not one in the middle, huh? Does everybody see that? There's not one in the middle, right? Because if we said, well, it's this one. No, it's not that one because he's got 3 left of him and 5 right of him, so he's not the middle. And it's not this one here because he's got 3 right of him and 5 left of him. He's not the middle. Do you notice they are together, the middle, aren't they? So actually there's 2 in the middle in this case. So when we have an even amount of them, there's 2 in the middle, not 1. Did you catch that? That'll be really important for how you do medians. If you have an odd amount, remember the first problem with the David Robinson basketball? We had 9. We had 9 numbers, which is an odd amount. We have a middle finger. Maybe this will help you. I'm not going to flip you off, but I'm just going to demonstrate. We have a middle finger. We have a middle finger because we have 5 fingers. We have an odd amount, right? So we have a middle finger. If we only had 4 fingers, we wouldn't have a middle finger. We'd have 2 in the middle, wouldn't we? Does that make sense? So if you have an even amount of things, you don't have 1 in the middle, you have 2. If you have an odd amount of things, like 5 fingers, then you have 1 in the middle. So that's true for all amounts of numbers. So odd, so therefore it's all about if you have, for the median thing, if you have an even amount, then you take the 2 in the middle and you average them, You add and divide by 2. Add them and divide by 2. Does that make sense? So if you have an even amount, like if we had 4 fingers, you'd have 2 in the middle. If you have an even amount, just add them up and divide by 2, because there'll be 2 in the middle. If you have an odd, like the David Robinson problem, we had 9, so there was just 1, we just grab it. But if you have even, you got 2. So I'm just going to take the 2 in the middle, which is minus 1.7 minus 1.7, and divide by 2. Does that make sense? And of course, what's the average of negative 1.7? What's the average of the same number twice? It's that number. It's all kind of silly. I mean, you can do it formally. You get negative 3.4 divided by 2 is negative 1.7. So, right, when you average the same number, it's going to be itself. So that's the middle number, negative 1. So that would be the median number for that data set. Is that good? Questions I can answer on that? We're going to go to part C, so I'll flash off of this when you're ready. Actually, I might just put part C up here, because I don't want to rewrite those numbers. Okay, let's do part C right up here. Now in part C, what they say. I better get rid of this too. Minus 1.7, minus 1.7. Oops. Part C, they say the new average. And what do they do? In Part C, they're saying same data set. What did they do? Oh, one less data point. What did they take out? Oh, the 11.4. Looks like they took out the 11.4, huh? So they said, okay, let's take the same data set. Let's take out the negative 11.4. So I'm going to scribble this guy out. And so now they want me to find the new average. I'm not going to bother with that. Just add them up and divide, whatever. But then how about the new median? How do we come up with that new median? Well, now there should only be one number in the middle, right? Because now we have an odd amount of numbers. So there's only going to be one in the middle. So which number's in the middle? It's the second negative 1.7. So there's 3 above it and 3 below it. So I don't have to average anything. Of course, the answer comes out the same because they put the same two numbers in the middle. I don't know why they did that. It wasn't really well planned, but there it is. It's for a different reason. It's the same answer for a different reason. Everybody see that? Now we have odd, so we have 1 in the middle, not 2. We have a middle finger now. Good? I got to say weird things like that. Helps people remember it. I'm always afraid of being the Charlie Brown teacher, the wah, wah, wah. All right, I'm going to move on from that. If you're good, moving along. Okay. So, part A. I'm not going to worry about the average, just add them up, but I'm going to do the median. So for part A's got the numbers 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and they want the median. How do we find the median? Well, they're already in order from low to high. They're already in order from low to high. How do we find the middle? So go ahead, I'll let you do that. Go ahead and find the middle. Median's the middle, right? They're already in order. So find the middle. So you got to decide first off, are there an even amount of numbers up there or odd? How many numbers are up there? 3 to 12 is how many numbers? You know the easy way to figure that out? I mean, you can just count them, but just who's missing? From 1 to 12 is 12 numbers, right? If they started at 1 and went to 12, we all know that's 12 numbers, but 1 and 2 are missing, aren't they? So it's 12 numbers missing 2. So how many numbers are up there? 10 numbers. That's the quickest, sure way to say there's 10 numbers up there. 1 and 2 are missing out of 12 numbers, right? So there's 10 numbers. So does that mean there's going to be 1 in the middle or 2? Just going to have a middle finger? Going to be 2 numbers in the middle, huh? So grab the 2 numbers in the middle and average them. So what 2 numbers are in the middle? Is it the 6 and the 7? Yeah, not 6 and 7, because that would be 3 numbers below and 5 numbers above or something. So it's the 7 and the 8, isn't it? Because that's 4 above, 4 below, yeah. It's the 7 and the 8. Good, those are the 2 in the middle. What's the average of 7 and 8? What's the middle of 7 and 8? 7.5, right? You could do the formalities if you want. Add them and divide by 2, and you will get 7.5. It's the middle. It's the middle of 7 and 8. Halfway between $7 and $8, $7.50. So that's the median on that one. Is that good? Questions on that? Let's do part B. Let's do the median for part B. How part B? It's 3, 4, 5, 6, 7, 8, 9, 10, 11. This time it stops at 11. Find the median. How many numbers up there? How many are missing? Just 1 and 2 are missing again, huh? And out of 11 numbers, so there's 9 right there. There's 9 numbers up there, so they have a middle finger? Yeah. 9 numbers have 1 in the middle. Grab the 1 in the middle. So we don't need to take 2 and average them, just grab the 1 in the middle. Who's in the middle? The 7. It's right in the middle, 4 above and 4 below. No averaging needed. There's 1 in the middle when you have an odd amount. Good? On that, finally, part C, I'll put it up here. They just put C's next to them. It doesn't matter. 2C, 3C, 4C, 5C, 6C, 7C, 8C, 9C, 10C, 11C, whatever. Just do all your work with a C. How many numbers up there? Only the number 1 is missing. So 11 numbers missing 1, 10 numbers. So is there 1 in the middle or 2 in the middle? Must be 2 in the middle, right? When you have an even amount, 10 numbers. So which 2 is it? Yeah, it looks like 6 and 7. Yeah, because it's 4 above, 4 below, yeah. 6 and 7 are in the middle, 2 numbers in the middle, 4 above, 4 below. Good. And then what's the average of the average them? It's going to be 6.5C. Average of $6 and $7 or $6.50, C. And you just throw that C at the back. They're just going to have a C on all the answers. There we go. Good on that? So put them in order, grab the 1 in the middle, or the 2 in the middle if there's an even amount, and average them. Moving on. Talk more about it tomorrow, too. This does trick people a lot. Okay. So first off, what is this even talking about? What does frequency mean? How many of them? Yeah. So when it says there's a score of 0 with frequency 4, that means there's 4 zeros. And then there's a score of 10, 16 times. That means there's, I'm going to write it out. I think it'll help. 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16 of them. That means there's 16 tens in the data set. That's what that means. And then next we have the number 20, 14 of them. So I'm going to write 14. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 20s. And finally, 6 30s, right? Yeah, 6 30s. 1, 2, 3, 4, 5, 6. Now, you don't have to write these out, but I'm teaching it, so I want to make it as clear as I possibly can. That's what that means, right? So when they start asking me questions, remember, that's what that really is describing. You don't have to write that out as long as you have that in your mind and you know that's what it's really saying. Okay, so, but it might be worth it on a test just to be sure. What did it take me, 2 minutes at most? Probably, it might be worth it. All right, so first off, they want the average. That could be a little painful. You got to add all those numbers up and divide. Can we do that? Can we figure, you have your calculator? Can we figure the average of all those numbers? I mean, the answer is 15.5, but can you come up with it? The average of all those numbers? Now, what's going to be the quick way to add those all up? Yeah, that's why we have multiplication, right? So we don't have to do that. Yeah, can you see that basically all you're going to have to do is say, I have 4 zeros, which is 0. I have 16 tens, which is 160. I have 14 20s, which is 280. And I have 36s, which is 180. Add those up. I can even do it without a calculator. 620. Right, so I added those up, 620, and then I divide by the number of numbers. Right, well, what's the number of numbers? Well, that's whatever the frequency totals. So that tells you how many of each kind of number, right? If you add up the frequency, add this up, what's that going to be? 30, 40? Divided by 40. We're going too quick. Do you see how I'm adding them all up without, in a way that's quicker? Right? So I just, 4 zeros, 16 tens, 14 20s, 6 30s. Add them all up, divide by 40 numbers, because frequency is how many numbers, right? 40 numbers, 31, so 15 point, well, yeah, the answer is 15.5, yeah. Half of 31. 15.5. That make sense? Quick way to do that? Okay. Now, part B, let's find the median. Let's find the 1 or maybe 2 in the middle. How many numbers do we have? Are we going to have 1 in the middle or 2 in the middle? Yeah, because we have 40 numbers, right? That was that 40 numbers. That's an even amount of numbers, so we're going to have 2 in the middle, aren't we? 2 in the middle. So find the 2 in the middle. So which 2 are in the middle? We should do that. So make sure you got the 2 in the middle. All right, so the 2 in the middle. I think what it is, isn't it this last 10 and the first 20? Aren't those the 2 in the middle? If you count them, I think there's 19 numbers below them and 19 numbers above them. Is that true? Yeah, because there's 20 numbers total, 4 and 16, that go up to the, all the 4 zeros and 16 tens, that's 20 numbers, that's half the numbers, huh? So that means the last 10 is the 20th number. You with me? So this must be the 20th number, which means there's 19 numbers below him. This is the 21st number, which means there's 19 numbers above him, to be 40 total. So those 2 are the middle, so what do you average them? 10 plus 20 divided by 2, it's 30 over 2, 15. That's the median. The average of the 2 in the middle. Good there on that? We're going to get a different way to do this in a few minutes, I think, if we have time to get there. I'll leave this if you're good. Is that okay? We're going to come back to tables. Tables often trick people, so we'll do a couple more of those tables. But remember, a table means a whole bunch of numbers, just not showing them all, right? Let's talk about quartiles, okay? So consider the data set, first quartile, third quartile, okay, yeah. So we're going to talk about quartiles. How do we, yeah, let's just go into it. So I'm going to give you some rules here for what a quartile is. If you guys know, if you're watching a football game, basketball game, and it says we're at the end of the first quarter. That's what the first quartile means. So first quartile means end of the first quarter. So if somebody says, hey, how far are you in the basketball game? I say, well, the first quarter just ended. What percentage of the way are we through the game? 25%, right? We call that the 25% point or percentile mark is what we say. We'll get into what that word exactly means. Yeah, 25% of the way through the game. I don't need to write percentile. I'll come back to that later. Just 25%, right? So what that is you find P25. Now, what am I talking about P? Well, there's a special thing to find. I'm going to give you this information now. You're going to want to we'll use this a lot. So here's how you find the Pth percentile. The Pth percentile. What you do is, number one, you order the numbers low to high. You got to put them in order. So we're gonna have to take that data set and reorder it, huh? It's not even in order right now. So I really want to make that point clear because people get all messed up who forget to reorder their data sets. So you gotta reorder from low to high. So you could do that first. Number two, you've got to take P over 100 times n. And what is n? N is number of numbers. It's the number of numbers. N is the number of numbers. Okay, and then there's two options for this. It's a little tricky here. A, if you got a whole number, if the answer, well, if you get, let's just say if you get a whole number, average the number in that spot and the next spot. And I'm running out of room here, so I'm going to have to come up here. Part B, if you get a decimal, round up and take the number in that spot. And when I say up, I mean even 0.1 goes up. There's the plan. That probably sounds mysterious till we actually do it a few times. But there's the plan. There's how you find the pth percentile. You put the numbers in order, low to high, then you take this little formula here, p over 100 times n, where n's the number of numbers. If that comes out to be a whole number, then you take the number in that spot and the next spot and you average them. If it comes out to be a decimal, you round it up. Even 0.1 goes up, everything up. Take the number in that spot. That's the pth percentile. Now, what is that? How does that work? So, I'll let you copy that down, and then we're going to do this. So, yeah, I don't really have room right here. So, getting that copied down, okay? So, it's all right if I flash forward. Got it? Okay. So let me go to a blank screen. Same thing. Okay, so let's find the first quartile. So first quartile, bring it up here. Again, first quartile. Oops. First quartile is P25. Right, 25% of the way through the game. 25th percentile. So that means when you take the formula P over 100 times N, that'll be 25 over 100 times N. What's N? Oh, I forgot to order the numbers. What am I doing? What am I doing? Let me reorder the numbers. Number one, reorder. So let's take these numbers and read. What's the first one? -7. Then -4, -3. I'm putting them in order, low to high. -4, -3, 3. Maybe I should underline them. 3, 4, 6. 3, 4, 6, 7, 7. Did I get them all? 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4. I can't count them. 1, 2, 3, 4, 5, 6, 7, 8, 9. No, I'm missing one.
You missed a 7.
Oh, 3 sevens? Oh, you're right. Thank you. Yep, you're right. There we go. Now I got them all. So it's good to double check. Add them up because it's easy to mess up. Okay, so I reordered them, low to high. Now, they want the first quartile, which is P25, right? 25%. If at the end of the first quarter, you're 25% through the ball game. Okay, so what does that mean? Take P over 100 times N. So that's P, 25, over 100 times N. What is N? What is N? It's the number of numbers. How many numbers do we have here? 1, 2, 3, 4, 5, 6, 7, 8, 9. N equals 9 numbers. Times 9. 9, 9, 4, 2.25. Is that what that comes out to be, I believe? because a fourth of 9, half of 9 and half of 9 again. 2.25. Good to there. Now, what do I do with that 2.25 thing? What does that mean? Well, that's what, let's go back to the instructions again. So remember what you do. You put the numbers in order. We did that. You take the P over 100 times n thing. We did that. And if you get a whole number, then you take that spot and the next spot and you average them. If you don't, if you get a decimal, that's what we got. We got a decimal. You round it up and grab the number in that spot. So I round up to 3. You know, it's not rounding off. That makes sense because if it would round, it's closer to 2, but we round it up. 3, and the answer is not 3, it's the third number. So first number, second number, there it is. Third number, which is -3. Does that make sense? It's a pointer. It's saying take the third number. The answer is not 3. It's saying take the number in the third spot. It's an indicator. It's of where to go. It's pointing right there. So the third number in the list is a quarter of the way through the list. That's what it's saying. Into the first quarter. That looks like about a fourth of the numbers, doesn't it? It's not exactly because it's not really divisible by 4. Does that make sense? What I just did there. Let's try. That was part A. Let's try part B. It's saying find the third quartile. Find the third quartile. How do you find the third? What do you think third? Say into the third quarter. Watching the ball game, into the third quarter. What percentage of the way are we through the ball game? That's P75. We're 75% of the way through the ball game. Right? Into the third quarter, basketball, football. Right? P75. So do the same thing. Use the formula P over 100 times N. See what you get. See if you can do that one. So P over 100 times N is 75 over 100 times N. What's N? Number of numbers, not 9 of them. So, I don't know, what is that? 3/4 of 9? 6.75? 6.75. What are you supposed to do with a decimal? What do you do when you get a decimal? Round it up. 7th number. Not 7's not the answer. The 7th number in the list. Remember, it's a pointer. Who's the 7th number? 1st, 2nd, 3rd, 4th, 5th, 6th, 7th. It is a 7, it turns out, coincidentally. The 7th number is the first 7. So that's why the answer is 7. That good? That's the third quartile. The 75% of the way through the data mark. Let's try, I'm going to move on to part C. They're going to add a little more data to it. How are we doing? I hope we're going to make it through this. We're number 4. Okay. We good there? Good if I flash off that? We okay? We've almost got this. It's a long problem. Let's find part C. So now they're adding to what do they add to the data set? Oh, adding one more data point. What did they add? Just this -6 at the back, I guess? Yeah. So let's order these things from low to high. So -7, -6, I guess. So order them. -7, -6, -4, -3, 4, -3, 3, 4, 6, 7, 7, 7. I got them all. 1, 2, 3. How many numbers we got there? 1, 2, 3, 4. 10 numbers? Yeah, 10 numbers now. All right. So now it says the first quartile and the third quartile for the new data set. Can you find the first quartile? I forget the answer there. It should be -4. See if you can get that. The first quartile of the new data set now. So that's the P25, right? First quarter, into the first quarter, 25% of the way through the game. So first quartile, P25, so P25. So it's P over 100 times N, so 25 over 100 times N. N is 10 now, right? 10 numbers. 4 through 10, 5, 2.5. What do we do with the decimal? Round it up, third number in the list. 1, 2, third number. Sure enough, there it is, -4, which we already had the answer. Yeah, there it is, first quartile. So that's 1/4 of the way through the data set, the number -4. Good to there? Questions on that one? All right, let's find the third quartile. Third quartile, P75. So it's P over 100 times N. 75 over 100 times N is 10. Is that 7.5? Rounds up. 8th number in the list. Well, it's that 7 again. That's the 8th number in the list. So it's the number 7. Sure enough, it is. That too quick? That good? Questions I can answer on that? So just put them in order. Use the P over 100 times N formula. Okay, I'm going to move. Okay, so part A. We have the numbers 1 to 100. So the numbers 1 to 100. And we're trying to find, first off, they want us to find the 75th percentile. So I'm not spelling that right. So how do we find the 75th percentile? Well, P over 100 times N. So P is 75. 75 over 100 times N. What's N? What's the number of numbers? Yeah, 1 to 100, there's 100 numbers. Huh. Everybody see that? So it just comes out 75. You with me? So far, so good. How are we doing? About 15 minutes left here. Am I losing you? I can tell if I'm losing you. Is that the right answer? What's the real answer supposed to be? Yeah, it says over here it's 75.5. Well, I thought it was 75. What did I do that's wrong? Well, we need to go back to these instructions. It says it right there. It's in English. I'm just giving you a hard time. I'm just kidding you. I know math doesn't always read like English, though. What does it say there about how we do this? I just disobeyed the rule. Which rule? Good job. Yeah. Well, if your answer is a whole number, you're supposed to be, that's not the answer. First off, the first thing you get out of that P over 100 times N is never the answer. It's a pointer. It's a locator, right? It's telling you where to look to find the answer. So the 75 or the whatever you get at first when you do the P over 100 times N is never the answer. It points to the answer, right? When it says 75, for example, it's saying it's the 75th number in your list. That might be, who knows what that number is, right? So, so first off, remember, those are pointers. I really want to emphasize that because this is where students get confused. This is what happens. So remember, the first answer you get is just a pointer. It's not, you've not arrived yet. It's just telling you where to go, right? Not only that, also, when it's a whole number, you're supposed to take that spot and the next spot and divide them by, average them, divide by, add them up, divide by 2, average them. Whereas if you get a decimal, you're supposed to round up and just grab that one spot. Remember? That's what the instructions say. So when I get this, where am I? Here, when I get this 75, that means 75th and 76th numbers averaged. Right? Remember, when you get a whole number, you're supposed to take that spot and the next spot. Well, what is the 75th number in the list? Well, it's 75. And the 76, add them and divide by 2, hence 75.5. Does that make sense? Why we're getting that? So if you get a whole number, you got to grab that spot and the next spot. It's like having 2 numbers in the middle, for example. Right? You got to average them. Whereas if you get a decimal, you round up and just grab that one number. That's like having an odd amount and one in the middle. Good. Is that good? Let's try the 90th. As this is exactly what confuses people. I hope you're still tracking with me after talking at you for 2 hours here. Try the 90th. See, this is it. This is the issue that gets people in this. This is one of the things that gets people in this section. They get confused between the pointer and the actual answer. So same formula, P over 100 times N. P over 100 times N. So 90 over 100 times N, the number of numbers, there are 100 numbers. So that just comes out 90. Good so far? P over 100 times N. N is 100 numbers. In this list, there are 100 numbers. We're still on part A, So what do you do when you get a whole number? Take the 90th and 91st and average them. Right? Whenever you get a whole number, you take that in the next spot and you average them. So what's the 90th number? 90 and 91 averaged is 90.5. There we go. Good? Is that making sense? When you get a whole number, take that spot and the next spot and average them. Is that okay? Questions I can answer on that? But they're going to change it up now in parts B, C, and D. You ready for me to move on that? That okay? A was straight ahead because it was straight through the numbers. B will be a little more tricky. Okay, B. Now they're going to change the data set. Look what they do with the data set now. 0 to 100. So for part B up here, so for part B, we're going 0, 1, 2. So we start at 0 all the way to 100. So how many numbers do we have then if we're starting at 0? 101, right? You got 100 plus one more number. You got 101 numbers. Yeah, so give it a try. Same thing. They want the 75th percentile, P75. You know the formula, P over 100 times N. And what's in now? 101. 101 numbers, right? Use your calculator. It's going to be, I don't know, 75 point something. 75.7? Okay. So you see what you're supposed to do. I'll let you do that. All right, what do you do when you get a decimal? What does the formula say when you get a decimal? Don't we round up? 76? Got it, 76. I see lots of that on the exam. And they have that option there. They're just baiting the hook. Those publishers that make these test bank questions, they just put the bait on the hook and throw it in the waters of your test, and many fish bite. What's wrong? I did what they said, right? I rounded up. I did not do what they said. I've got to read those instructions more carefully if I think I did. See, math is about precision, right? And it isn't like, I love history, so I'm not putting history down, but really, Abraham Lincoln was the 16th president. That's it. No deep waters. I love history. I'm not putting it down. But I'm saying math is like Chinese or something. You got to really get the details out. You can't be casual with your grabbing of math. Be really precise and clear. What does that say? What are you supposed to do? If you get a decimal, okay, that was us. We got a decimal, right? Round it up and you're done. Oh, no, there's more words. Round it up and take the number in that spot. Don't just round it up and you're done. I've seen many, many students do that. So don't just round it up and we're done. We round it up and we go, it's not the number 76, it's the 76th number. Remember, it's a pointer. It's a pointer. It's not the end result. It's saying go there and find there. It's like a road sign. Yeah, maybe that'll help. It's a road sign. You don't say, there's you're headed to Tahoe for the weekend. And you see the first road sign that says Tahoe. We made it, kids. It's Tahoe. No, it's the road sign to Tahoe. Keep going. Follow the road sign, right? Remember, this is just the road sign. It's saying your answer is waiting for you in the 76th spot. Well, what number is that? What, in this list here, which number is in the 76th spot?
75.
You see it now? Because the first number is 0. The second number is 1. The third number, the 4. You see the pattern? Right? You take the spot number and you subtract 1, and you get the number in that spot. Fourth spot, a 3. Third spot, a 2. First spot, I lost my train of thought. Anyway, you subtract 1, right? So 76th spot, going to be a 75. Yeah, that's why the answer is 75. So remember, that thing's a road sign. That's the part that gets everybody. They do the N, P over 100 times N, they get it, and then they want to stop, right? That's a road sign saying, here's where you find your answer now. That's a road sign. If it's a decimal, round up, follow the road sign. If it's a whole number, follow the road sign to that spot and the next spot and average them, right? All right, let's try 90th percentile. So try that, 90th. So P90, right? Give that a try. P over 100 times N. So 90 over 100 times, and N's still 101. We're still dealing with this list of 101 numbers, huh? You probably get 90.9 or something. What it is? Yeah. 90.9. And so you round up 91, but that's a road sign. It's 91st number, huh? It's a road sign saying go find the 91st number, and so the 91st number will be the number 90. Right, again, it's always, in this particular list, it won't always be, but in this particular list, it's always one below the spot number, right? The 91st number is the number 90, like the 76th is 75. 90 is the, 90 there. Oops. Good to there, we doing well? How many more of these should we do? We do that'd be even. That'd be odd. I don't know. We could do C and D quick. So you probably have got it kind of at this point, right? I think. Questions on that one? Is that good? Getting better? Maybe we should, I want to practice it enough to where you're flawless and you won't mess it up on the test. So let's try part C. Part C, we're doing the numbers 1, 2, 3, 4, 98, 99. We're going all the way to 99. 99 numbers. 99 numbers. So 99 numbers. So n is 99. So find the 75th. Find the p equals 75. Can you do that? Give that one a try. Yeah, I don't think it's going to be hard. I don't think there's any tricks anymore. P over 100 times n, 75 over 100 times n. N is 98 numbers now, right? No, 99. I mean. Oh, did I? Yeah, 99. Yeah, there's 99 numbers here. 99. So is that like 74 point something? What is it? 74.25. Okay, and then you know what you do with the decimal? Round it up. 75th number. Well, the 75th number is 75, coincidentally, because they started at 1 this time, huh? Does everybody see the difference? The first number is 1. The second number, we didn't start at 0. That's what threw that other data set off a bit. Does everybody see that? So the 75th number is 75. So this part's easy. Part C and D are straight ahead. I don't think we need to mess with them. We good there? I'll move on to number 6, if you're good with that, so we can finish up this section. Okay, so number 6. In a particular year, a total of 1,452,803 college-bound seniors took the same aptitude test. Assume that the test scores are scored from lowest to highest, and that the sorted data is D1, D2, da-da-da-da-da. Determine the position of the median. Determine the position of the first quartile. Determine the position of the third quartile. Now, median. What does median mean? If I said, hey, how far are you in the basketball? I'm watching the basketball game. Well, how far is it? I'm at the median point. What does that mean? 50%, huh? Which is halftime, right? Median is P is 50, isn't it? So we can just use, so median, remember I told you we'd have another way of finding median? So rather than that other way I told you, where you got to put them all and mess around, you can just do P50. It'll work the same. The other way will work too, but this will be quicker. Just whenever they ask you median from now on, just do the P50. For the formula, I mean, you know, like the P over 100 times N, but P is 50. So this will be, I'm getting lost. This will be 50 over 100 times N. N is how many numbers? That's the 1,452,803 numbers. So what is that? Something really big. 726,401.5. Did I do that right? I think I did. Yeah. 401.5. That's half of that number. Okay. And then what do you do with the decimal? Round it up. So 726,402. That's the spot that we're supposed to find. We don't even know what that test score is. We're just saying whatever test score is in that spot, that's the one, the position, right? We found the position, the location. So whatever the 726,402nd test score from the bottom up is, that's the one that's the middle, the median test score. So the other two are the same, right? First quartile, third quartile, those are exactly the same. Found the way we did it a few minutes ago. P25, P75 on that. Is that making sense? Is that good? Maybe we will stop there. Yeah, so we're just a couple minutes early. So, all right. We have finished up